Hey, we're recording. I'm going to continue. This is part 2 of that lesson 2-4 about the parameter changes. I think it'll be easier to access these if they're shorter videos. I debated whether to do the long one or the short one. I don't know if there's a right or wrong answer. If you've got feedback, be sure to let me know. Now we're going to try something different. Instead of that 1 that's in front of the x squared that's invisible getting larger, I'm going to make it get smaller. So 1, I'm going to make it smaller, make it a half, and then I'm going to make it a fifth. So let's just see what happens. I'm going to go back to exit and get rid of that one. Yes. Get rid of that one. Yes. So now 1/2, you on the Casio, the easiest thing to use the ABC button. 1, ABC, 2, and that gets your fraction, x squared. And that's what it looks like, 1/2 x squared. So I keep the original one because that's what I'm comparing it to. And so let's see, it's going to go first, second. 1, 2. What happened this time? Let me go back and put the third one in. 1, ABC, 5, x squared. Did I get it in right? Yes. Oh, I got too many of those things. Let me go back in and delete one of those. This is what it looks like on this calculator. 1/5 x squared. I'm gonna 1, 2, 3. Look how wide that last one is. So this time it opens up. It becomes wider. Now this one is going to be a little bit different. Let me get it turned back on. I'm going to go to y equals this button. That's where most everything starts. And let's get rid of that one. I'm going to use this arrow and clear it. And then arrow down and clear. This is using more the clear button than the delete. I guess, I'm not sure if delete will work, but I'm used to using the clear. Now here, this calculator is older and finickier. It does not have a fraction key. So if I want that fraction in there, I've got to carefully take the fraction, little careful, scoop it up and move it over to the calculator with parentheses. So I've got to use parentheses, 1 divided by 2. Close the parentheses. And that's that's certainly something different. Now that just has my 1/2. Then I'm going to put the x and squared. And then to take a look at that one, I'm going to graph it. So there's the first one, and there's the second one. Let's go back to y equals, and I'm going to use this little arrow down. And again, I have to use the parentheses. Parentheses, 1 divided by 5 parentheses, x squared. There we go. Graph it. And there we go again. It's just so what's happening this time as the number gets smaller, the graph gets wider. So here's my x squared. The next one is a little bit wider, but they're all still connected down here at the same vertex. They still go through the origin. This last one goes super wide. So as A gets smaller, the graph gets wider. This gets narrower and this gets wider. Now, mathematically, this is called a compression. Think about, like, if you put pressure on it, it's going to squash it out. Oh, let's see. Like if you press on it, it widens out because there's pressure from the top, and then it's going to squish out the sides, kind of thing. And last one, oh, not last one, because there's two more. I'm still here. I don't know if you just see white. I just see white screen. There we go. So there's two more, and then I'll close it, but there will be three parts to this video. Now what we're going to do, and what happens instead of a 1x squared, the one that's there, it's invisible, that I make it negative. When a is negative, what happens to the graph? Now this is the x squared, and what happens, it just, well, the math word is reflects. Now in my book, I call it a flip. It flips over. It's like here, and then it flips over there. It flips. And to be specific, when we do reflections, we generally start with a reflection across the x-axis. This is the x. This is what's acting like the mirror. And when they get real specific, they will use all of this language, reflects across the x-axis. We'll get more advanced, we'll reflect this way, but right now we're reflecting up to down or down to up. So if in front here is positive, it opens up. If the x squared term is negative, it opens down. So that's something to keep in mind. Now there's one last thing, and I'm not going to show that on the calculator. You'll see that one, but I am going to show this one. The front page is things that happen in front of the number, in front of the x squared, in front of x squared. If it gets bigger, it gets thinner. If it gets fraction, it gets fat. That's not my little thing. So it's like, if you see a fraction in front, it makes it fat. Fraction in front, a fraction in front makes it fat. And the alliteration of that might help you. It's just a parabola. It's not personal. We can call it fat. Don't call me fat, but I am. Anyway, that's neither here nor there. What this is happening is at the end. It's after the x squared, and I'm either adding a number or subtracting a number. So when we start right back at the beginning and compare to our parent function. This is the parent function, and this is the x squared. That's this one I'm going to put in black. Now what happens, and I'm going to go back to here. I'm going to push exit and get rid of some of those. And the second one I want to put in is x squared. Now this is a different place. I got to x squared plus 5. Now let's just look at that one. There's x squared. I don't see this one. It's actually hiding because I've got it so much over here. No, where is it? Let me go back. Okay. Well, it's not showing. That's really, oh, I know what, I know. Duh. Here we go. Because this is up, no. There it is. It moved up. Yeah, my brain's on Corona. Corona time is a little bit off. Okay, so here's x squared, and then plus 5, it moved up. Now it's if I keep going, it's still there. It didn't get smaller. It's just that you don't see all of it. It just moved it up. And back here. x squared minus 5. Can you guess where it's going to go? There's x squared. And you can see something there. And if I go down, you'll see that one. And again, it's not that it's bigger. It's just that you're seeing more of it, you know. So the plus 5, if k is positive, the graph shifts up. Typo. If k is negative, shifts down. So here's x squared, 1, 2, 3, 4, 5. It's up there. 1, 2, 3, 4, 5 down. It's down there. Now, like if you look at this, it just, you know, as you hide it, it's kind of this optical illusion that it looks bigger or smaller. It only just takes that vertex and moves it either up or down, but the shape of it is still going to be the same. And that's it. So the idea is that we want to be able to do matching like this, equations with graphs, without a calculator, by just thinking about these rules. And I'm going to go ahead and keep going. Hopefully this video is not too long to be useful to you. What I want to do is go back to this parent function. This is kind of like regular, skinny, fat. So there's regular width, thin ones, and wide ones, if we put it nicely. So to find out if it's regular, the easiest thing to do is look for this point. This point, I don't want to make it too dark. 1, 1. 1, 1 is this point right there. If I go to the vertex, I go over 1, up 1, and it's right on the line. That means it's part of the parent function. It's an x squared, or it's, you'll hear me say regular. So my nickname for this one is regular. So we're going to see if it's skinny or fat based on this 1, 1. That's my trick. So like here's our first picture. It looks kind of like the parent function. So I want to see, is this one regular, skinny, or fat? So I'm going to check. If it's the parent function, it'll have the 1, 1. So I'm going to go to the vertex and go over 1, up 1. It missed it. Now, since this is outside, is this regular, skinny, or fat? Is this narrow or wide? Wide or fat. What makes it wide or fat? A fraction in front makes it fat. So my choices, that's it right here. Y equals 1/2 x squared. Because this one is wide. And I could figure that out without a calculator just by knowing that trick and looking at the graph. Over 1, up 1. So let's go to this one. This one also looks like, it looks a lot like my parent function. But I need to check with the graph paper. And I'm going to check for that point 1, 1 from the vertex. Over 1, up 1. Oops. This one is too thin, skinny, narrow. Now, what makes it get skinny? I don't have my little, it's if I take this and stretch it. X squared, 2x squared, you know, every time you pull on it up more, 2x squared, it gets skinnier and skinnier. So it's going to have a number in front. So the one that has a number in front is this one, 2x squared. So this one is 2x squared. There we go. Now what about this one? Well, this one right away, it's not starting at the right point. Now, they all start at the origin, so this one has moved down. This one moved down Start from here, 1, 2. So this one went down 2. So for it to go down, let me see, is it regular, skinny, or fat? I'm going to start the vertex, over 1, up 1, right on the money. Regular, down 2. It takes a little bit of practice to get these down, but once you get them, they're super easy to start to see these without having to really flip to that calculator all the time. You just read it. Now this one got flipped upside down. So usually the U is this way and it's this way. So it's, instead of being this way, it's this way. So it got flipped, which means the first thing I'm going to see in that equation is a negative. Now is this one regular? And from here, so it went 1, 2, it's flipped and up 2 from the origin, 1, 2. You count the spaces, 1, 2 spaces. But from the vertex, over 1, this time is down, and it's regular. Regular 1, up 2. Flipped, regular, up 2. And that's how that works. Now the practice that you're going to do is just some matching. And if you learn to do this, you want to first find which one is the parent function. Now you want to make sure that you don't get one like here. This could be it, right? Because parent function goes like that. And it's right on the vertex. Do you use that trick? Over 1, up 1. No, this one's too fat. That one's not at the right position. Over 1, up 1. So once you know your starting point, you know the idea. If you're not using a calculator, I'd love to you know, work with you so you can see it and read it the way I'm reading it. It'll be to your benefit, and I'm happy to do that. So good luck with that. And